Very good morning, everyone. I request the comparing team, please, to start over the session.
Hello, everyone, and good morning. Respected speaker for the today's session is Ms. Poornima Thiyagarajan, Madam, Honorable Chairman of SIETK Group of Institutions, Dr. K. Ashok Raju, Sir, Honorable Principal of SIETK, Dr. K. Chandrasekhar Reddy, Sir, Honorable Principal of SISTEC, Dr. M. Janardhan Raju, Sir. Convener of today's webinar is our beloved HOD and Professor of ECE Department, Dr. Ratna Kamala, Madam. Coordinators, students, and all other dignitaries. We extend a warm welcome to all of you for this webinar on current trends in communication technology, jointly organized by IETE Students Forum, Department of ECE, and Institution Innovation Council, SIDDHARTH Institutions of Engineering and Technology, Puttur. Prayer. Prayer is an action. It is the process of talking with God in order to achieve a purpose. So let's begin the program by seeking the blessings of God Almighty with a prayer song. Pratibha will take over the song.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि.
Thank you, Pratibha. Now I'll hand over the session to Tarani to continue. Tarani, are you there?
Good morning to all dignitaries and participants. It is my privilege to introduce the speaker of today's webinar, Ms. Poornima Thiyagarajan. This is a webinar on current trends in communication technology by a speaker, Ms. Poornima Thiyagarajan, Lead Communication System Engineer. Now I am here presenting Ms. Poornima Thiyagarajan brief profile. Ma'am did her Master of Engineering Department of Electronics and Communication Engineering based on Communication Systems and Bachelor of Engineering. Moreover, her technical skills are programming languages and operating systems as Windows and documentation tools like Microsoft Office. Some of her research and industrial experiences include Lead Communication System Engineer, Junior Researcher in ISRO, Industrial Production Engineer. Her best career vision is to work in a challenging environment, demanding her skills and efforts to explore and adapt herself in different fields, and realization among the opportunities where she get to continuous learning. Research interests are communication systems, digital image processing, digital signal processing. Mainly her favorable personality traits are commitment to work, adaptability, goal-oriented person, problem-solving abilities, good coordination, and persuasion skills. She is an inspiration to all the leading brains in technical and professional-based works. Ms. Poornima Thiyagarajan guided the students in preparation and presentation of research findings. Madam also mentored undergraduate and master students for their projects under design of microstrip and its performance optimization, design of dual band half, and so on. Ma'am's personal objective is seeking excellence in chosen professional field through self-motivation, hard work, and augmentation of core skills required to effectively deliver goods. She always wanted to work where the knowledge and excellence are given their due. Poornima ma'am knows everything about RF devices and antenna design, leading to develop spacecraft communication architecture. Poornima ma'am spent 3 years of research associate for ISRO sponsored R&D project at Amrita University, and she is currently pursuing her PhD at Amrita. Thank you, Poornima ma'am, for your incredible work, talent, and inspiration, and for being with us today. And over to you, ma'am.
Thank you so much for the warm welcome. Good morning, all. So I'm Poornima Thiyagarajan, currently pursuing as a lead communication system engineer at SMC Space Missions Company, which is an Australian-based company. R&D is in Bangalore. So thank you very much for giving me this opportunity. So let's begin with the session.
Kosal.
Yes, sir. Madam, could you able to share the screen?
Yes, sir. Yes. Once again, I'll share my screen.
Right, ma'am. Right.
Sir, hope my screen is visible now.
Perfectly visible, ma'am. Please
Thank
go
you.
ahead. Thank you.
Thank you. So today's topic is communication technology. I'll start with the basics of communication first. So the basic communication, which is mean by the transfer of information from one place to another. So it should be like very efficient, reliable, and secure. In simple term, we can define it as a process of conveying information from the source to destination. So though we have the communication, we need a channel or the system to process the communication. So we call it as communication system or the subsystem or components which acts together to accomplish information transfer or exchange. So an electronic communication system is just a transferring of information using an electrical signals as a field of signals. So this is the so there are two major communication systems. One is the wired communication, another one is the wireless communication. There are some specifications needed for the communication subsystem. So first is the rate of information transfer, which is defined as the amount of information that is being transferred from the transmitter to the receiver. So that should be communicated from the source to destination, and it will determine the physical form and technique used to transmit and receive information, and therefore the way of system is designed and constructed. So the purity of signal received should be more efficient. That is, the received signal must be same as the transmitted signal without any loss or interferences in between the channels. So there is a recording environment, and the electrical signals are passed to the channel, and there will be a signal processing devices incorporated in a communication system, and there will be a listening environment where the listeners can acquire the information which is being transmitted, and the storage devices to store the information signals, and there will be a transmission channel. So this is the basic communication system. So it should be it should not be a complicated system or kind of thing. So it should be very simple. So any mode of communication system must be convenient in order to be effective, efficient to use. As far as the reliability is concerned, the user must be able to depend on a communication system. It must work when needed and transmit and receive information without any errors, or it can be some acceptable errors. There are like 3 dB loss, which we cannot what to say, we cannot control that. So above 3 dB loss is different. So like with some acceptable errors, we can receive the information. So the elements of communication systems are, first is the communication source, which is the input source, and you have the message signal, which is being transmitted. That is, the message signal is the signal which contains the message that is to be transmitted. So this message signal can also be called as a baseband signal or the modulating signal, where the signal undergoes the process of modulation. So that we call it as a modulated signal or a baseband signal or a message signal. So next comes the encoder. So encoder is the circuit which basically converts the information signal into a coded digital bits. That is the binary bits, zeros and ones. And the next is the channel medium, where the information is being transmitted from the transmitter to the receiver. Decoder, if we have the encoder in our system, we definitely needs a decoder. So this decoder performs reverse operations and recovers the original information signal from the coded bits. So it accepts coded binary data as the input, and here the number of inputs accepted by encoder will be like 2n. So the decoder will also accept the bits as 2n. Next is the receiver. So receiver which gets the information which is transmitted from the transmitter, so without any loss or interferences. So this is the basic communication system steps involved. So next is the this is the schematic diagram. So like here the signal is being transmitted via the transducer. So here the electrical signals are getting transmitted through the electronic process, and the transmit. So here the electrical signals are converted into a coded bits, and in order to transmit as the electromagnetic waves. So here at the receiver, it that signals gets passed through that, and again the person can receive the signal at the receiver end. So here the input transducer is used. So it is basically to convert the message to a form suitable for the particular type of communication system. So basically the microphones example, and apart from transducer, we can also use transponders and transceivers in order to transmit and receive the information. So the transmitter is basically the process that the input signal to produce the transmitted signal that suited the characteristics of the transmission channel. So here the modulation signal we can call it as the transmitted signal, and the other functional performance like amplification and filtering also be done at the communication subsystems. So the channel we call it as a transmission medium. So it's a medium that bridges the distance between the source to destination. So for example, here the atmosphere. If we consider the wireless system, so the signal passes through the atmosphere, free space. And if it is like a wired system, the signal passes through the coaxial cable, fiber optical waveguides, etc. So signal undergoes degradation from noise, interferences, and distortions. So here we have to minimize all those things. In order to minimize, we have 5 main criteria to look into it. So one is the capacity of the transmission medium, how far the input signal can be transmitted to the output, and the distance between the source to the destination, the performance. So there should not be any degradation in the performance. So with minimal errors, we can transmit the signal from the source to destination. And fourth one is the security purpose. So we should be very careful in security. The information, whatever we are transmitting, that should not be leaked or getting interfered to other systems. So fifth is the cost. So the costs should also be very minimal in the installation, operation, and maintenance process. So here the diagram shows that the input signal is transmitted through the transmission medium, or we call it as a transmission channel, and the output signal is generated. So here the signal is attenuated. Attenuated means there will be some kind of losses which is occurring during the transmission process. So there are two main categories of channel. One is the line, and another one is the free space or the radiated media. So the line, if we consider the line, it is a conducted media, and here the channel made up of metallic cable. So it can be a coaxial cable or a twisted pair or parallel wires and fiber optical cables. So through the cables, the components of the communication systems are connected and the transmission takes place. Whereas in free space or the radiated media, there will be a propagation of electromagnetic waves or signal. So the applications oriented are the radio broadcasting, microwaves, and satellite transmission systems. Coming to the losses, so first is the attenuation and the distortion and addition of noises to some degrees to the transmitted signal. So these are the common loss which occurs in the transmissions. So it depends on the type of transmission medium used, and no signal processing is used in the medium. It's just a medium where the transmitter is connected to the receiver. So receiver is the part where we can extract the received or the desired signal from the channel output. It converts it to a form of suitable for the output transducer. For example, here the process takes place, the demodulation and decoding process takes place. So output transducer is the it's kind of transceiver and a transponder which converts the electrical signal as its input into a form of desired signal by the system used. So here the examples are like the loudspeaker, we can say, and the tape recorders, and also our PCs. So there may be some unwanted, undesirable effects happen during the transmission process. So one is the attenuation. Major thing is the attenuation. So which is like reduces the signal strength at the receiver. And the distortion. Distortion means the waveform perturbation. That is some kind of disturbance happens in the waveform, electromagnetic waves caused by the imperfect response of these systems. So here we can reduce this by using the equalizers or the limiters in the circuit. This can be limited. So next is the interference. Interference means the contamination by the extraneous signals from the human sources. So if suppose in space you have 2-3 satellites, so one may and in every satellite you will be using these antennas and filters, all those RF components. So like one should not be interfered with others. So that should be avoided. And next is the noises. So noise is the random and unpredictable electrical signals from internal or external to the system. So here we concern about the SNR and BER, that is the signal to noise ratio and bit error rate. So here the signal to noise ratio is the measurement of or the performance of this noise relative to the information analog signal. Whereas the bit error rate is used in the digital system in order to measure the deterioration of these signals. Deterioration means how far the signal strength is decreasing in the medium. So that should be avoided. So next is the two major signals. So classification of two major signals are, one is the analog signal and another one is the digital signal. So analog means it is a continuous variation. So here we assume the total range of frequencies or time. So all the informations are transmitted over here. Whereas in digital, we take it as a sample and it won't be a continuous stream. So there will be on and off pulses. So analog signal will be like this, and we use the analog to digital converter in between them in order to convert it to a digital signals. So if we consider about the digital communication system and analog communication systems, we have both advantages and disadvantages. So coming to the advantages of digital communication systems, it is like inexpensive, and there is a privacy preserved, like data encryption can be good and can merge different data over here, and error correction is also possible. So we can correct the errors at the process. Whereas the disadvantages is it acquires a larger bandwidth, that is broadband, and like synchronization problem is relatively very difficult. Whereas coming to the advantages of analog communication systems, here we have a smaller bandwidth, narrow bandwidth, and synchronization problem is relatively easier over here. Whereas the disadvantages, the analog communication systems are more expensive than the digital communication system, and here there is no privacy and cannot merge different data. Also, the error correction capability is not possible. So as I already said, the baseband signal, which is also called as the modulating signal or the message signal. So it's an original signal either in a digital or an analog form. In a communication system. So here the baseband signal, we call it as M of T, and whereas here the carrier signal will be added to it while modulation, and we'll get it as a modulated signal, that is M of T cos omega ct. So here the example is voice signal, that is the frequency ranges differs from 300 Hertz to 3400 Hertz. And the transmission of original information, whether it's analog or digital, it is directly transmitted into a transmission medium. And the modulated signal, as I already said, it's a baseband signal, which its original frequency is shifted to higher frequency to facilitate the transmission process. So yeah, we are talking about this baseband, all the signals. Why we need actually is that the concepts and parameter of baseband transmissions are used in modulation transmissions. And here the performance of baseband transmission is used as the standard for comparing modulation techniques. we have so many modulation techniques, and the baseband signal is not suitable for long distance communication. So hardware limitation is also there. It requires very long antenna, and the interference with other waves is also possible over here. So modulation is the process of changing the baseband signal to facilitate the transmission medium. There are some process involved in it. One is the frequency translation, such as AM, that is amplitude modulation, frequency modulation, and phase modulation. Next comes the sampling and coding techniques, such as pulse amplitude modulation and pulse coded modulations are involved in it. And we also have a keying techniques. So ASK, that is amplitude shift keying, phase shift keying, and frequency shift keying techniques are involved in the process of modulation So here the types of modulation, if we consider the types, we have analog modulation, digital modulation, and keying modulation. So analog modulation is the type of modulation where the frequency translation method is got by changing the appropriate quantity in a carrier signals. Whereas the digital modulation is the result of changing analog signal into binary ones by sampling and coding techniques. And the keying modulation is the digital signal, which is like subsequently modulated by the frequency modulation, either by using one or other analog methods. So why we go for modulate and what are the necessary? So basically we have to reduce the noise and interferences. So how we can reduce in the sense by using proper frequency where noise and interferences are minimum, and we can increase the power that is somewhat costly and may damage the equipment. And the frequency assignment. So here for TV and radio broadcasting, each station has different assigned carrier signal. We cannot use the same carrier for TV or the radio broadcasting. So here the multiplexing process is involved. Multiplexing process means it's combining several signals for simultaneous transmissions on one channel by placing each other signal on different carrier frequencies. So now comes to the communication technology. So communication technology is basically an electronic communication. So people now connect with each other by using technology such as telephones, mobile phones, social networks, radio, television, etc. So what are the importance of communication technology is like it can connect easily worldwide and became more fun communicating with other people's updates you about the world news. So it's very popular. So where it starts, so the history of communication technologies. So the communication was difficult in the ancient days. So people used letters and symbols, typewriter, then fax machines and telephones, answering machines evolved in 1800s. So then the radio comes out later, then television, social networks, mobile phones, computers, laptops to communicate nowadays. Now it becomes very easy to communicate in worldwide. And there are some drawbacks like in the ancient days. So one is the lost writing skills nowadays, and there is not any non-verbal communications, security issues, and misusages of communication is also happening. So coming to the economic impact, so everything relies on the communication technology nowadays. So this system has real impact on our economy. So global communication technology becomes the global economy, and the communication technology, which is like production economy to service economy. The cultural economy and media is like evolution of televisions, and media has a major role in communication technology. So updating us via television and social networks. So media can be disadvantaged by making false statements also. Coming to this data security, so here the communication technology improves, but privacy becomes weaker. So developers of social networks like Google, Apple can invade your privacy in their products. Example, Google Glass. So how communication technology works, like it works with the satellite and radio towers by sending the data from a person to another. And the process can be done in seconds. Also, the communication technology gets better and better every decade. So coming to the radio frequency, that is the signal which is transmitting through the free space, which we call it as electromagnetic waves. So this RF is related to electromagnetic signals, and it is characterized by frequency and amplitude. Basically, the RF is synonymous with the wireless and high frequency signals, starting from the amplitude modulation radio, that is the frequency range from 535 kilohertz to computer LAN, local area network, at the frequency range of 2.4 GHz, and also from 5 GHz to 90 GHz. So it comes under terahertz applications. So here the electromagnetic spectrum is divided into subcarriers, or we call it as a band, with each band having a different name or boundary. So here we use the ITU, that is International Telecommunication Union, for registering the frequency bands in satellite communication. So here the electromagnetic spectrum consists of many waves, like starting from the radio waves to the gamma waves. These are the radiation types, and the frequency range differs from starting from 700 nanometer to 400 nanometer for the visible light, which is placed in between the infrared and ultraviolet. So here the longer wavelength to shorter wavelength, and the energy at the infrared, at the end of infrared, will be low, and at the beginning of ultraviolet will be the high energy. So that's what it's mentioned over here. So coming to the RF properties, we have 5 properties. So one is the amplitude, frequency, wavelength, phase, and polarization. Here this GIF shows that the electromagnetic signal passes through the air, atmosphere, free space. So the blue indicates the electrical signal, and the red indicates the magnetic signal, so which is like perpendicular to each other. So coming to the basic terminologies, like amplitude. So amplitude is the difference between the maximum and minimum value during one cycle, and it can be measured in volts, and it will be related with power or strength of the signal. Whereas the frequency is concerned, like the number of times a signal go through a complete cycle, that is up and down, one cycle, one sine wave. So that can happen in 1 second, and it is measured in hertz. Third terminology is like wavelength. It is a function of signal's frequency and its speed through space. So here from this end to here, we have measured it as 1 hertz, and the whole cycle we call it as a wavelength. Here, so it is measured by lambda equal to c by f. So lambda is the wavelength in meters, and c is the speed of light, and f is the frequency. So next is the phase. Phase is nothing but the method of expressing the relationship between the amplitude of 2 RF signals that have the same frequency, and it is measured in degrees. And next comes the polarization. So polarization is nothing but the electromagnetic waves, which refers to the direction of electrical field. It can be like polarization can be of many types, like circular polarization, spherical. Next, I'll come to that slide. Okay. So here the frequency. So frequency mainly we concentrate on 900. If suppose 900 megahertz, so the wavelength will be like 0.33 meters, and the graph looks like this. For 2.4 LAN applications, lambda will be equal to 0.125 meters. So it becomes a little narrower. And for 5 gigahertz, the wavelength is 0.06 meters, and it becomes even more narrower. So coming to the polarization, we have 3 major types of polarizations. So one is the linear polarization, another one circular polarization, and elliptical polarization. So circular polarization, in that we have 2 major classifications. One is the left-hand circular polarization and right-hand circular polarization, which we'll mainly use in satellite communication. So here the scientific notations are like, we call it as 10 power minus 3 is milli, and 10 power minus 6 is microwatts, and like 10 power 3 we call it as kilo, and 10 power 6 mega, and 10 power 9 is giga. So these are the scientific notations we use in RF. So next comes to the bandwidth, which is the difference between the upper frequency and the lower frequency, and we can measure it. The unit is hertz. So this is the band. So it shows the graph between the gain and the frequency. So starts from 20 Hertz to 20,000 kilohertz. So next comes the radio frequency spectrum. So here we have starting from very low frequency to terahertz. So the very low frequency, the symbol we in short term we call it as VLS. The frequency range starts from 3 kilohertz to 30 kilohertz. So now we are concentrating at present, the current trend goes on terahertz application. So terahertz frequency involves 300 to 3000 gigahertz. So the RF technologies, here we have major RF technologies evolved in the computer communication technology. So here, once sorry. So here, first comes the wireless network technology. Next is the concept of ISM, that is industrial, scientific and medical frequency bands. Comparison between various wireless technologies, then Bluetooth, Zigbee, Wi-Fi, WiMAX, and LTE, that is long-term evolution, which is called as 5G and 6Gs. So these are the evolution of RF technologies. So wireless network technology. So these are the technology which is like Bluetooth, Zigbee, Wi-Fi, WiMAX, and LTE advanced. So that standard, corresponding standard is for Bluetooth is IEEE 802.15.1, and the network definition is wireless personal area network. For Zigbee, the standard is IEEE 802.15.4. And here the network definition is, it is mainly concerned with the low rate wireless personal area network. And for Wi-Fi, the standard is IEEE 802.11, and it is wireless local area network. And WiMAX, for WiMAX, the standard is IEEE 802.16, which is mainly concerned for wireless metropolitan area networks. And the LTE advanced, which is mainly concerned for the 5G and 6G, all those things. So IMT advanced technology is used. So coming to ISM frequency band, ISM is basically an acronym for Industrial, Scientific, and Medical Frequency Bands. So here, the frequency ranges starts from 900 megahertz band, and 2.4 for LAN applications, and 5.0 gigahertz and 60 gigahertz band, which is the terahertz band. So here, anyone is allowed to use radio equipment for transmitting in these bands, provided the specific transmission power limits should not exceed it. And without obtaining a license, we can acquire these bands. So coming to the ISM frequency bands. So ISM frequency band at 2.4 gigahertz can be used as transmitter using frequency hopping technology. So it's a kind of communication technology. So here the total transmission power will be less than 100 microwatts, and the power density will be less than 100 microwatts or 100 kilohertz. Second technique is transmitter using direct sequence spectrum technology. Here the total transmission power will be less than 100 microwatts, and power density will be less than 10 microwatts or 1 megahertz. So the maximum channel data rates, here the network for all those Bluetooth, Zigbee, Wi-Fi, WiMAX, and LTE advanced, the maximum data rate is like for Bluetooth, it's 1 megabits per second, and it goes up to 24 megabits per second, though the version is evolved. So version Bluetooth version 4 for IoT applications, Internet of Things. And for Zigbee, it is nearly 250 gigabits per second. And for wireless LAN applications, the maximum data rate used is 11 megabits per second, and 54 megabits per second, and 1 gigabits per second. For WiMAX, it is 134 megabits per second, and for LTE advanced, it is 30 bits per second, or that's a spectral efficiency. So IEEE definition of wireless PAN, that is personal area network. This is used to convey information over a short distance among a private, intimate group of participant devices. So here the connection can be made through wireless PAN, involves little or no infrastructure or direct connectivity to the world outside the link. This allows small, power efficient, inexpensive solutions to be implemented for a wide range of devices. Coming to the Bluetooth technology, it is widely used in wireless PAN technology, that is wireless personal area network, that is known as Bluetooth version. It has the version of 1.224, and the IEEE 802.15.1 standard specifies the architecture and operations of the Bluetooth devices, but only as far as physical layer and media access control layer are concerned, and here the core system architecture is involved. Whereas like the higher protocol layers and applications defined in usage profiles are standardized by the Bluetooth technology. So the Bluetooth enable the connection of devices and communicate wirelessly through short-range ad hoc networks. So in ad hoc networks, there won't be any base stations, and we call it as a piconets. So piconets means these are established dynamically and automatically as Bluetooth-enabled devices which enter and leave radio proximities. So here up to 8 devices in on piconet, that is 1 master and 7 slave devices can be connected, and maximum range is 10 meters. Coming to the Zigbee technology, so here we use the low range wireless personal area network, which is simpler and less expensive than Bluetooth devices. So the main objective to use Zigbee is it's very easy to install, reliable data transfer, short range of operations, then extremely low cost, reasonably battery life is there. So these are the major main objectives to use Zigbee technology. And here the 2 different device types can participate in this network. One is full function device, which can operate in 3 modes serving as a personal area network. And another one is the reduced functional device, which are intended for applications that are extremely simple. So this FFD can communicate with RFDs, or other FFDs, while RFD can only communicate with FFDs. Coming to the RF components, so here we have 2 major classifications. One is the active component, another one is the passive component. So active components are basically the amplifying components, whereas the passive components are the 2 terminal components, or 2 or 3, more than 2 terminal components. So here the active components involves the transistors and tunnel diodes, triodes, vacuum tubes, which is called as valves, rectifiers. So all these are active components, whereas the passive components are resistors, inductors, capacitors, and transformers. So passive components plays an important role in RF and microwave circuits. For example, inductors are commonly employed to tune out the capacitance of the transistors by performing resonance circuits. So here the inductors and capacitors are together used to design the filters and impedance matching circuits. Coming to the filter, which filter is basically a passive RF passive device, which can allow a certain range of signal in a certain range of frequency band. So here we have classification of filters also, I'll explain. So here filters are the linear 2-port network designed to pass a specified band of frequencies while attenuating all the signals outside that band. And it is a frequency selective circuit. There are 4 major classifications of filters. So one is the frequency selection. Depending on the frequency selection, we can classify it as low pass filter, high pass filter, band pass filter, and band stop filter. Concerning to the response, we can classify the filter as Chebyshev filter and maximally flat filter. And coming to the technology, we can classify it as lumped filter, waveguides, then SAW filters. And coming to the frequency band, we call it as wideband filter and narrowband filters. So these are the major classifications of filter. Filter is a RF passive component used in the communication subsystem. So the application, coming to the application of RF technology, So we have so many applications mainly involved in like mobile communication, satellite communication, cellular and wireless networks, wireless sensor networks, military purpose, and electronic warfare. So we have so many applications over here. And next is, these are some of the RF components which I would like to show. So first is the one second. So this is METOP SG satellite, which is basically it's a series of 6 metallurgical satellites developed by European space agencies. You may refer as like, which may refer as EU MESAT. So this is launched from this is going to be launched from 2024, and it's going to stay in space for more than 10 years, like nearly 2039. Up to that, it's going to withstand over there. So here, these are the launchpad systems concerned. And absorptive filters. These are the filters, and these are the response used in the satellite communication. And the basic structure of MIMO system. MIMO is the multiple input and multiple output. So we basically for in order to have more gain and not to have the good transmission range or something, we go for MIMO kind of systems. So these are some of the filters and their response. So basically the RF components looks like these. And duplexer means it's also a 3-port device. So which is duplexer means it's a 3-port device, which is a passive filter component that can transmit and receive the signal based upon the frequency ranges what we are using. We have so many bands of frequencies: S band, L band, C band. So depending on that, we use the duplexer in our communication subsystem. And the duplexer looks like this, and the performance of the duplexer will be shown as this. So this is the Rosetta spacecraft, which was a space probe built by the European Space Agency, and it was launched in the year 2nd March 2004. So it performs a detailed study of comets, and it was manufactured by European space agencies. And the cost is nearly 1,000 crores. So I'd like to show this GIF. So here, around the Earth, we have so many orbits, and the closest to the Earth, we call it as Leo orbit. That is, Leo orbit. So here, how far the distance is from like 160 kilometer to 1,600 kilometers. So above the Leo orbit, we have Neo orbit, medium Earth orbit, and the distance from the Earth will be like nearly 10,000 kilometers to 20,000 kilometers. And beyond that MEO orbit, we have the geostationary orbit. So it's a special case of GSO where the satellites always appear stationary above some point on Earth's surface. Thank you. Hope my session is so it's not boring, and it contains dense of information. Hope gist of communication is involved. Like, all can be able to know what is meant by communication technologies, RF technologies, applications oriented to it, and latest satellite technologies involved.
That was great, ma'am. I request the students, if they have any doubts, please interact with madam, and you can ask directly.
Poornima, hello.
Hello. Yes.
Yes, ma. What you are working in R&D work, no, ma? Communication side.
Yes, sir. Yes, sir.
can you give some suggestions for our student? What are the requirements is based on R&D work for EC student? What kind of
Sure.
works?
Okay. So basically, as a communication system engineer, so they should have a deep knowledge in any of the subjects, like involved in RF or microwave engineering or the signal processing, any kind of things. But like they should have a deep knowledge in that. Any one subject they can take, they can have a deep knowledge in that. And so many opportunities are available. Like in R&Ds, we develop a new kind of projects, like depending on the requirements we used to design, we come up with the configurations, we do analysis of all those things. So that kind of to say a student should have a deep knowledge. Any subject they can take, but like I would like to suggest them to go in deeper so that they can excel in their field.
Okay, ma'am. Thank you, ma'am.
Thank you, sir.
Kosal, sir?
Yes, sir. Yes, sir. We'll wait for some more doubts, sir.
Okay,
Participants, if you have any doubts, please raise your hand. I would be unmuting you.
Good morning, ma'am. This is
Good morning.
Rajnikant.
Yeah. Hi.
So may I know how to use that filters? You said the different types of filters, no? They are based
Yes.
on frequency response, based on frequency selection.
Yes.
How these are useful in the communication system?
Depending
real
on
time,
the
real time.
depending on the application and requirements, these filters are used. So basically, I've shown major 4 classifications of filters. Yeah, so like we have low pass filter, high pass filter, band pass, and band stop. For example, band pass filter is concerned. So if you want your information to transmit in a particular frequency range, you can go for band pass filter. And if you go for band stop filter, you can transmit your signal in a particular. You can avoid the particular frequency band, and in another in the rest of the bands you can transmit the signal. So depending on your applications and requirements, you can use those filters in your system. Hope you got it. Yeah.
Yeah. Thank you.
Thank
Yeah,
you.
madam. Good morning. My name is
Good.
Veer Babu.
Yeah.
Yes,
Hi.
madam. I have a little doubt regarding communication. While communication between transmitter and receiver, there will be focusing impedance in free space
Yeah, sir.
impedance. Actually, the free space impedance is 120 pi. Actually, the thing
Okay,
is,
sir.
while designing the antenna, we should design as identical transmitter. I mean, identical transmitting and as well as receiver.
Yes, sir.
So the thing is, which is not matching the impedance between transmitter and receiver. So there is no proper communication.
Yeah, sir. Correct.
So we need to design means according to free space impedance, we should design the antenna, both the transmitting and receiver.
Correct, sir. Actually, in our designing these RF components, we use initially we use all those calculations, ideal calculations to design the antenna. But at the end, in order to match your impedance or something, you have to tune your system. There are some tricks. For example, like if you tune the length and width of your antenna, you can that impacts on the return loss. So you have to, there is no other way, sir. In RF, like you have to tune your RF component to match with the impedance. Initially, you can follow those calculations, but later you have to tune your
Yes.
component. Yeah.
Madam, actually, the thing is, it's very difficult to matching the impedance. So that in while designing the antenna transmitter, so
Got it, sir.
lumped equipment is there. So we have to matching the at least nearby the impedance value. Then only
Yes,
you
sir,
can
yes.
do this communication, right, madam?
Yes, sir. Correct.
Yeah, madam. Thank you, madam. Wonderful
Thank you,
session, madam. Thanks. We got lots of information regarding this session. Thank you, madam. Yeah.
Thank you. Thank you, sir.
Good morning, ma'am. My name is Sriram.
Good morning. Yeah.
Can you tell us what are the issues in current communication system, ma'am?
So issues like previously also, now also we are facing some this kind of attenuation, interferences, noises. So in satellite communication also, we are launching so many satellites, and in space, in geostationary orbit, we have those kind of interferences. Even so many people fails in this. Like if we launch and the major failure comes to the communication systems, like we couldn't able to communicate. So major thing is like the attenuations, interferences, and the noises are the major issues. So we have to, even though there are some techniques, but still there are some issues like these. So we have to avoid this.
Thank you, ma'am. Thank you for your wonderful session.
We'll take the last doubt, ma'am. After that, we'll proceed with the formal vote of thanks and closing of the session.
Sure, sir. Sure, sir.
Good morning, ma'am.
Good morning.
Ajay Kumar.
Okay. Hi.
Ma'am, can you briefly explain about the keying modulation?
So keying modulation involves this amplitude shift keying, phase shift keying, and frequency shift keying techniques. So if you want to brief it, like it is mainly used in the communication system. So depending on the amplitude shift, that is the amplitude shift keying process. Depending on the phase changes, we go for phase shift keying, and depending on the frequency, we go for frequency shift keying. Also, there are other modulation techniques involved, like quadrature amplitude modulation, all those things. So depending on the application and the requirements, we use these modulation techniques in our communication system. So basically this amplitude, phase, and frequencies are involved, and depending on that, we are using this keying techniques.
Madam, we have a query in the chat box by Dr. Madhusudan. He's
Okay,
asking
sir.
what companies will recruit in communication engineering? Any top players or companies that you would list out?
Sir, I can say like communication, like Qualcomm, Synopsys. Then if you consider about the satellite area, like Airbus, Boeing, and many nowadays, many startups are evolved in aerospace engineering where they require communication system engineer. So students can focus on those areas if they are interested in space.
Right, ma'am. Would you suggest any internships for the students, ma'am, related to who are interested in especially space electronics?
Yeah, sure, sir. Like, let me know in future, like if the students are really interested, I can take it as an intern.
Super, ma'am. That's great to hear. Ashwini, are you there?
Yes, sir.
Yeah, please present the vote of thanks.
Yes, sir. On behalf of the Institution of Electronics and Telecommunication Engineering, Students Forum Department of ECE, and Institution Council Innovation Council of Siddharth Institute of Engineering and Technology, Puttur, we extend our deepest gratitude to our resource person, Ms. Poornima Thiyagarajan, for sharing her knowledge in this webinar, Current Trends in Communication Technology. We thank our Honorable Chairman of Siddharth Institutions, Dr. K. Ashok Raju. Sir, our principals of SIETK and SISTEC, Dr. K. Chandrasekhar Reddy Garu and Dr. M. Janardhan Raju sir, for being a constant motivators. We thank the convener of this event, Dr. P. Ratnakamala Madam, Head of the Department of ECE, and also the President of Institution Innovation Council, for her solid support and timely monitoring in every aspect as we grow. We thank the coordinators, Dr. P.G. Kupusamy sir and Dr. Koshlendra sir, and all the participants.
Thank you, ma. It's incredible. Poornima, ma'am, it's a pleasure to have you again.
Thank you, sir. Thank you, students.
For more sessions from you. Shall we all have a group photograph, please? I request all the participants to please turn on your cameras. Requesting all the participants, please turn on your cameras. This program is also live casted on YouTube, and we'll be sharing the link with all of you. Please turn on your cameras. We'll have a group photograph with our resource person, Ms. Poornima Thiyagarajan, madam. I know it's hard to turn up on a Sunday, and I appreciate your enthusiasm. We have around 100 plus participants at the peak time of this session. Now we have around 93, which is quite a good number. And I appreciate all those people who joined with great enthusiasm. Cheerful smile, please. Thank you all. We'll be sharing the feedback link. Madam, I'll be sharing this session recordings and photos with you in a short while.
Thank you.
Yeah.
Thank you, ma. Poornima.
Thank you, sir. Thank you, sir.
I hope the feedback link is visible on all of your screens, along with the QR code and the link. So I'll be posting the link in the chat box as well. So requesting all of you to please give your valuable feedback on this session. Thank you. The feedback link is now available in the chat box. You can either access the feedback form through the link in the chat box, or alternatively, you can scan the QR code, which is available on your screen. those who have submitted the feedback may leave the session. Thank you.